Okay, so we're going to go over radiation characteristics for a third time for me. Yay! Okay, so the X-ray beam has different characteristics. It has quality, quantity, and intensity. Quality determines the energy and the penetrating power. X-rays with shorter wavelengths have more penetrating power, which we know, and it's controlled by kilovoltage or kVp. Voltage is the measurement of the electrical force that causes the electrons to move from cathode to anode. It determines the speed of the electrons. An increase in voltage increases the speed of the electrons, and electrons strike the target with greater force and energy. Voltage is measured in kilovolts or kVp. Maximum or peak voltage is applied across the X-ray tube. Dental radiography units and adjustable settings are from 60 to 70 kV, and it's fixed at 70 kV. So kVp, this regulates the speed and energy of electrons. It determines the penetrating ability of the beam. An increase in kVp results in higher energy beam and more penetrating power. So an increase in kilovoltage, the film would appear darker. A decrease in kilovoltage, the film would appear lighter. Contrast. This is important for showing the differentiation, how dark and light areas are on an image. So low kilovoltage peak creates a high contrast film, which is where you see a lot of blacks, whites, very few shades of gray, and that's good for detection of caries. High kilovoltage peak creates a low contrast image which has many shades of gray, and that's good for detection of periodontal or periapical disease. Exposure time. So this is the interval of time during which X-rays are produced. They're measured in impulses or seconds, and they are inversely related with the kilovoltage. So when kV goes up, exposure time has to go down. If kV goes down, exposure time has to go up. Quantity means number, N for number, of the X-rays produced in the X-ray unit. This is controlled by milliamperage. This regulates the temperature of the cathode filament. If milliamperage goes up, temperature goes up, and number of electrons goes up, and number of X-rays emitted from the tube goes up. Adjustable settings is 6 to 8 milliamperage, and it's fixed at 7 milliamperage. So an increase in milliamperage increases the density, which results in a darker image. Decrease in milliamperage decreases the overall density, which results in a lighter image. So any increase in exposure factors increases density. Exposure time and milliamperage, those are inversely related. Everything that we went over was direct. Now this is inverse. So if milliamperage is increased, exposure time goes down. If milliamperage goes down, exposure time must go up. X-ray intensity, so this is the product of quantity and quality during that time of exposure. The influencing factors is kVp, MA, exposure time, and distance. We know what this is. kVp, this regulates penetrating power. It controls the speed of the electrons traveling. The higher kVp has more energy and shorter wavelengths. Higher the kV, the more intense the X-ray beam. Milliamperage controls the penetrating power. It controls the number of electrons and X-rays produced. Higher milliamperage produces a beam with more energy, and it increases the intensity. Exposure time affects the number of X-rays produced. The longer the exposure time, the more X-rays are produced and more intense X-ray beam. Density is the distance, distance is the distance traveled by the X-ray beam that affects the intensity of beam. So it's inversely related. We use the inverse square law to calculate the distance. And the X-rays diverge from the origin, so they spread out to cover a larger surface area. As distance increases, intensity of the beam is reduced. So this is inverse. Think about when you're blow drying your hair. The further you are from your head, the less you feel the air, but the closer you get to your head, the more you can easily burn your head because the intensity has increased when you're closer to your head. That's what I think about. So like I said, the inverse square law. So if the distance is ever doubled, it'll always be 1/4. Distance is tripled, it'll always be 1/9. Distance is quadrupled, it'll always be 1/16. So basically, if you remember math, if you were to square 2, 2 squared equals 4. If you were to turn 4 into a fraction, it would be 4/1. Now if you want to inverse that, it would be 1/4. 3 squared equals 9, 9/1. Inverse that, 1/9. 4 squared equals 16, so 16/1. Inverse that, that's 1/16. And this picture basically just shows like how when you double it from, this is 2 squared, so when you double it, it's only 1/4. So you only see 4 things being affected, but if you half it, it's 4 times more intense.